briefly going to talk about the idea of domain and range of a function.
So looking back at our balance equation, b of x equals 2000 minus 400x, we're going to be looking at the domain and range of this function. For the other examples, we're going to look at it graphically, but since we've been talking about this equation this whole time, I'll just explain the domain and range of this function verbally. So the domain of a function is just all the possible x values that you could have. And the range of a function is all the possible y values that you could have for a function. So really all the possible and when I'm saying x, I'm referring to the independent variable, and when I say y, I'm referring to the dependent variable. So for our domain, the restriction on it, well, first of all, we said that domain is the input variable, so our input variable here is x for the months. So we're just trying to say what our domain is in between, or the restriction of our domain. So talking about the months, we're taking into consideration that we're not taking into account negative months. So the smallest month value that you could start off at is 0. And the highest value for the restriction of the months would be 5 months, because remember, after 5 months we had no balance left for this particular example. So our restriction is really from 0 to 5, and I'm going to have to include these because at 0 months I did have $2,000 in my bank account, and after 5 months I had $0 or money in my bank account. So I would have to include these values because I achieved these values. Yeah, so that would be the restriction or the domain for this function, because we started at time equals 0 and we went all the way up to 5 months, and that's where it capped out for the specific example. Moving on to the range, which is the dependent variable and whatnot, or y. That's the balance in this equation, as we mentioned earlier. So my range would be b. And so let's see what the restriction on that is. I saw that after 5 months I had no money in my bank account, so I would have to start at 0. And the greatest balance that I had was in the beginning when I had $2,000. So the restriction for the balance, or the range, would be from 0 to 2,000. Again, just that's how this problem worked out. And I would also have to include both of those because after 5 months I had no balance, and in the beginning I had $2,000. So that's really the restriction we had on the range. Yeah, so this was just a verbal explanation. We're going to look at the other examples through graphs so you can get a visual understanding of domain and range. Okay, so let's look at the concept of domain and range through a graph. Now I just want to point out that we're looking at a small image of what's going on here. These arrows let us know that this thing goes out in those directions forever. So there's a bigger picture that we want to focus on, not just what we're seeing here. So let's start with the domain, which is all the possible x values that a function could have. Let's investigate this thing. At an x value of 0, let's start at the origin. I could see that at an x value of 0, there is a point that corresponds to the function that lies on the function. So that x value is valid. Moving right along, at an x value of 3, I see that that x value lies on the function. So that x value is valid. And all these points that I skipped from 0 to 3, all of these x values would lie on the function, so they're all valid. And we could look at, we don't have to look at whole numbers, we could look at numbers like, I don't know, 5.25, 5 1/4. So at a 5 1/4, I see that I'm still on the line, so that x value is good. And moving to the left, I see that the same thing's happening. At an x value of -2, I'm still on the line, so that x value is valid. And just by this pattern, I could conclude that all of these x values are possible, and they're good x values that I could have for this function because they always lie on the line. So just by the gist of this thing and looking at it, I could see that the domain would be all real numbers in this case. Going this way and that way, an infinite amount, there would always be an x value that lies on the line. And talking about the range now, which is all the possible y values, we can see that the same thing's happening. So, for example, right here at this y value, we can see that that corresponds to an x value and whatnot. And at this y value of, let's say, 1, there's an x value that corresponds to it. So when you're looking at a line, as long as it's not horizontal or vertical, it's going to have all possible values for the domain and range.
Okay, still focusing on the concepts of domain and range through a graph. We looked at a linear function. Now we're looking at something that's quadratic, a parabola and whatnot. So let's start with the domain, which is all the possible x values that this thing could have.
Let's see. At 1, at this particular point, there's an x value that lands on the parabola. Moving to the right, I can see that all these x values land on the parabola. And again, we're just looking at a small image. This thing goes out left and right in all directions. Yeah, so looking at this thing, all these values to the right always correspond to a y value on this function. All these x values hit the function. And moving to the left, all these x values still hit the function. They're on the function. So all those possible x values are good and applicable. So talking about the domain, all the possible x values, they're all real numbers again for this parabola, because if I move to the right an infinite amount, I'll always still land on the parabola because those x values are valid. And if I move to the left forever, those x values will still be on the parabola, so all of those x values are valid. Now, as opposed to the range, which is all the possible y values we could have, well, first of all, just looking at the restriction, it looks like the lowest y value I have is right here at 0. Like that's the smallest y value I could have on this parabola, because -1, it's not on the function. So the lowest possible y value I could have on this thing is 0. What about the largest y value I could have on this parabola? Well, let's see. After 0, it just looks like it just keeps going up from there. Like it's symmetrical, so at -1 or at 1, looks like they're at 1. So anything that happens on this side is going to be a reflection on the other side. So at 2, it just looks like the y values are just getting bigger and bigger. And we're assuming there's arrows on this thing, so this thing just keeps going up. So if I were to talk about the range, the restriction on it, I would start with the smallest value I could achieve, which is 0. And it looks like the largest value I could have is just infinite amount. I could go up forever on this thing. So I would say that the range on this thing would start at 0, and it would go all the way up to infinity.
Okay, still looking at domain and range through a graph. Now we just have a parabola that's opening downward. So let's see how much could change from there. So let's focus on the domain, which is all the possible x values that we can have.
Moving along all these positions here, they all correspond to an x value. And again, this thing is going on forever, so I could see that moving to the right, all those x values would land on the function, so all those x values are valid. Moving to the left, as we talked in the previous video, it's just a reflection, so the same thing is going to happen. Moving to the left, all those x values are going to land on the function again, so those are all possible x values. So we could then again conclude that the domain of this function would be all real numbers. Going to the right an infinite amount or to the left an infinite amount, we're always going to have an x value that is possible. So the domain would be all real numbers. Now let's focus on the range, which would be all the possible y values. What I like to do is just look at the restrictions first of all and see where it caps out at. Right here you can see that the largest y value we could have is right here at 4. So that would be the maximum amount that I could go. So I could see that my range caps out at 4 because I can't go any larger than that. No point's going to lie on that parabola. And the lowest y value, this parabola is opening downwards, and there's arrows at the bottom of those that we can't see right now, letting us know that it's going to go down forever. So it looks like the range starts down at a very big negative number, like negative infinity, and it comes all the way up and stops at 4. So it looks like the range would be from negative infinity all the way up to 4.
Okay, thanks everyone for watching these videos. I know it's been kind of long. Functions has a lot of parts to it. So I thank you guys for being patient, and thanks, and I'll see you soon.